Welcome to 0-4, part 2 of the notes. These are the exponent rules, and you'll probably want to take a second and pause and write these down, but I'm going to talk about each one of these. If you've got two bases the same and they're equal to each other, that means the exponents are also the same. This will become important when we start solving them a little bit later on in the semester. On number 2, if you've got the same base and you're multiplying, you add the exponents. So that means 2 to the 2 times 2 to the 5 is 2 to the 7, because you add the exponents. If you are dividing, you're going to subtract the exponents. If you've got a negative exponent, we don't like negative exponents. So if you've got a negative exponent, you're taking that and you're actually moving it down to the denominator. So it becomes 1 over x, or a to the x. And when it moves, it becomes a positive exponent. Conversely, if you have a negative exponent in the denominator, you can move it up top, and when it moves, it becomes positive. Number 5 is a power of a power, and that just means that you are going to multiply your exponents. On number 6, I always kind of first think of it as ab to the x. Anything on the outside of the exponent or outside of the parentheses as an exponent has to be applied to the inside. On number 7, that's what we talked about in the part 1 of our video. On 8, anything to the 0 power is 1. On number 9, anything raised to the first power doesn't change its value. And for the 10th rule, 1 to any power is always going to be 1. These rules are going to be super important. Make those your friend. Let's do a couple examples with some more radicals. I know this was a little bit more from the first part of the video, part 1, but that's okay. On this one, our negative sign is outside the radical, so that's okay. And that's just going to be, so we're taking the square root of 169, negative 169, and that makes our answer negative, and the square root of 169 is 13. On the second one, I'm going to think of that as the cube root of 216 over the cube root of 125, which is going to give me 6 over 5. Leave it as a fraction. What I notice on the next example is, hey, I've got this negative sign right here, but I also have a even index. So, no real root. And on the last one, it's kind of hard to see that index. It's 5 to the 5th root of 243, and that is 8. If you did not know how to do that, or did I just say 8? I was getting ahead of another example. That one, oops. Alright, I'm getting crazy with the buttons here. That one is actually 3. And if you want to, you can do a factor tree. And this is where that 8 came from that I was thinking of. 3 goes in there 81 times. And then you can do another factor tree. 3 goes into 81 27 times. 3 goes in there. Oops. Three goes in there 9 times. So there are my prime factors. And that index of 5 tells me they need to be put into a group of 5. That's why that index is important. It tells how many are in each group. And only one from a group makes it out, and that's why it's 3. All right. Hope you enjoyed part 2.